Good day, engineers. Para sa video natin na to, ang i-discuss natin will be the sample problem for the ultimate bearing capacity equation regarding Terzaghi's equation and Meyerhof's bearing capacity equation. So, simulan natin on knowing what is stated in the problem. So, sabi dito, a foundation settles at a depth of 1.4 meter below the natural grade line. The soil where the foundation rests has a dry unit weight of 16 kN per cubic meter, saturated unit weight of 19 kN per cubic meter, and an angle of internal friction of 20 degrees, and a cohesion of 20 kilopascal. So you have to determine the ultimate bearing capacity of the following footing using the Terzaghi and Meyerhof's bearing capacity equation. So we will use the following bearing capacity factors. So syempre, una doon yung Terzaghi's table. Next will be alternate equation for bearing capacity factor for Terzaghi din. Then, the Meyerhof's bearing capacity factor for the Meyerhof's equation. So, for this video, ang isosolve lang natin will be letter A for the continuous footing which is 3 meter wide at yung water table is 1 meter above the base of the footing. So, para mas mabilis natin ma-solve yung problem, so kailangan yung problem natin is i-interpret natin into a drawing. So, I have prepared here the drawing for the problem. Siyempre, nandyan yung depth ng footing natin, which is, sabi nga, 1.4 meters below the natural grade line. So, this one will be the natural grade line. Then, we have here yung dry unit weight ng soil, which is 16 kN per cubic meter. So, yun yung sinabi niya. Then, sabi dito, we have a saturated unit weight of 19 kN per meter cube for the soil na na-cover ng water table natin. And sabi dito, sa problem, yung water table natin is located 1 meter above the base of the footing. So, that means, we have here, ito yung base ng footing natin. So, ito yung 1 meter above. So, ang matitira na dry soil will be 0.4 meters. Then, alam natin na that is a continuous footing and we have a continuous footing which is 3 meters wide. So, kung kukunin natin yung top view ng footing na yun, so, syempre, meron tayong 3 meters na width or base ng footing. Then, yung L natin is unknown and we shall use an infinite number. So, infinite siya kasi mahaba yan yung continuous footing na yan and of unknown depth, of unknown length. So, we are asked to get the ultimate bearing capacity using the different bearing capacity factor and also the two equations which is Terzaghi and Meyerhof's. So, yung given natin is, sabi dito, we have an angle of internal friction of 20. So, we have a phi which is equal to 20 degrees. Then, you have a cohesion equal to 20 degrees as well. So, ayan siya, 20. Then, we will be needing the equation for the ultimate bearing capacity on Terzaghi. Siyempre, sa Terzaghi muna tayo, which is, since this is a continuous footing, we'll be using QU is equal to CNC plus QNQ plus 1/2 gamma B and gamma. So, yan ngayon yung ating ultimate bearing capacity equation for Terzaghi. So, ngayon, kailangan natin kunin sunod yung surcharge on the second term, which is Q. So for our surcharge load, we have here, so for surcharge, so syempre, sa surcharge natin, ang papansinin natin dyan kung mula base ng footing pataas. So as you can see, meron tayong dalawang soil na makikita na bubuhatin ng base ng footing, which is ito at yung saturated na soil. So to get the Q or the overburden pressure or yung surcharge load, so we have here Q is equal to, so yung dry soil sa taas, which is 16, tapos yung height nun, which is 0.4, plus yung saturated soil na natitira, which is 1 meter high, and merong unit weight na 19 kilonewton per cubic meter. So, these are same soil pa rin. Kung ano man yung soil na nandun, syempre meron lang siyang saturated na unit weight. So, that will be 19 minus 9.81. Tapos, ita-times na natin yung height niya na, as you can see, that is 1 meter. So, that will be times 1. So calculating our surcharge load or overburden pressure, we have here 150 or 1,559 over 100, that is in kilopascals. Then, kuha naman tayo nung unit weight for our third term. Syempre, yung unit weight na yan is para doon sa soil na nasa bottom nung footing natin, which is ito, or at a depth B. So, syempre, hanggang depth B, saturated yung soil. So, ibig sabihin, ang kukunin natin na value for the unit weight will be yung gamma saturated minus gamma ng water. So, that will be yung effective unit weight, which is 19 minus 9.81. So, we can have here 919 over 100, which is in kilonewton per cubic meter. So, yan ngayon yung ating unit weight for our third term. Then, yung B natin will be the less dimension of the footing. So, the least dimension is 3. So, yun lang naman yung given din sa atin. So, that will be B is equal to 3 meters. Then, our cohesion is 20 and our angle of internal friction will be 20 degrees. Now, after getting this one, we will proceed in getting the bearing capacity factor. So, kunin natin si NC, NQ, and N gamma. So, ang first thing to do or ang ating pagkukuhanan ni bearing capacity factors is, sabi sa problem, kuha ka daw, it's either on the Terzaghi table or alternative equation for bearing capacity factor. So, unahin natin kunin sa Terzaghi table. So, which is this one. So, sabi natin, that is 20 degrees na surcharge or 20 degrees na angle of internal friction. So, this is the 20 degrees na angle of internal friction. So, we have, so, ayan siya. So, from here, we have an NC equal to 17.7. Tapos, ang NQ natin is 7.4. And the N gamma is equal to 5.0. So, ito na ngayon isa-substitute natin on our ultimate bearing capacity equation. So, now we have the bearing capacity factor. We can now solve the ultimate bearing capacity of our soil. So, we have here QU, which will be equivalent to 20 times 17.7, which is our NC, plus, so, Q and Q. So, ang Q natin is 1,559 over 100 times 7.4 plus the 1/2 gamma B and gamma. So, that will be 1/2. Our gamma will be 919 over 100 times yung B natin which is 3 and our N gamma which is 5. So, our QU now will be equivalent to a value 538.291 kilopascal. So, ito ngayon yung ultimate bearing capacity natin using the bearing capacity factor from the Terzaghi's table and also using the Terzaghi's equation. So, ngayon, punta naman tayo dun sa part ng alternative na equation for bearing capacity factors. So, for alternative equations, so we have here yung NQ natin. So, much better kung kabisado nyo yung values. So, that will be E raised to pi tangent of phi times tangent squared 45 plus phi. So, that will be plus phi over 2. So, now, kunin natin yung NQ natin from this equation. We have here E raised to pi tangent of 20 times tangent squared times 45 plus 20 over 2. Our NQ coming from this equation will just be equivalent to 6.3994. So, that will be our NQ. Next, yung NC naman natin, our NC will be equivalent to NQ minus 1 over the tangent of phi. So, that will be NC is equal to yung NQ natin, which is 6.3994 minus 1 divided by tangent of 20. So, our NC now, coming from this alternative equation, will be 14.8347. So, unitless siya. So, that are factors. Last one na kukunin natin will be yung N gamma. Our N gamma will be equivalent to a value 2 times NQ plus 1 times the tangent of phi. So, that will be 2 times yung NQ natin, which is 6.3994 plus 1 times tangent of 20. So, that will be an N gamma equivalent to 5.3863. So, unitless pa rin since this is a factor. Now that we have the bearing capacity factors, syempre hindi naman mag-iiba yung mga dati nating given dyan, which is yung C. So, naka-degrees pala to kanina. Sorry, this is in kilopascal. So, hindi mag-iiba yan. That will be C. Yun pa rin. Yung Q, yan pa din. Yung gamma natin, ito pa din. And yung B natin is ito pa din. So, ang nagbago lang is yung bearing capacity factors. So, that will just be QU is equal to CNC plus QNQ plus 1/2 gamma B and gamma. So, that will be, substitute natin yung values. So, yung C natin is 20 times yung bearing capacity factor na NC na nakuha natin, which is 14.8347 plus yung Q and Q, which is yung Q natin is 1,559 over 100 times yung NQ natin, which is 6.3994. So, dito na lang natin lagay yung kasunod, plus, so that is 1/2. Yung gamma natin is still 919 over 100 times yung B natin is 3 times 5.3863. So, calculating this one, we could have a value of QU which is equivalent to 470.7108. So, that is in kilopascals. So, ito na ngayon yung ating shape. So, ito na ngayon yung ating ultimate bearing capacity using the Terzaghi's equation and using the alternative bearing capacity factor equations. So, now, after the Terzaghi's equation, itry naman natin siya on the side of the Meyerhof's equation. So, for our Meyerhof's equation, so using Meyerhof's, so we have here the equation of Meyerhof's will be QU is equal to the CNC plus CNC times lambda CS, lambda CD, lambda CI plus the QNQ, lambda QS, lambda QD, lambda QI plus 1/2 gamma B and gamma, lambda gamma S, lambda gamma D, and lambda gamma I. So, ngayon, before we get the ultimate bearing capacity, syempre, ganun pa rin dito, hindi naman nag-iba yung cohesion natin, yung overburden pressure na Q, yung gamma, and yung B. Ang mag-iiba dito are yung bearing capacity factors, and syempre, meron na tayong shape, depth, and inclination factor. So, first, we have to compute our shape, depth, and inclination factor. Before getting those factors, kunin muna natin yung passive earth coefficient of the soil. Kasi kailangan natin yun to get the shape and the depth factors. So, to get the passive earth coefficient, we have here Kp is equal to the tangent squared of 45 plus phi over 2. So, we have here the tangent squared 45 plus the 20 over 2. So, our passive earth coefficient will be equivalent to 2.0396 na unitless value for our passive earth coefficient. Now, after getting the passive earth coefficient, diretso tayo on our shape factors. So, for our shape factors, simulan natin sa lambda CS. Lambda CS is equal to 1 plus 0.2 Kp B over L. So, alam natin that L is in infinity. So, substitute lang natin yung other values bago ko explain. So, 1 plus, so 0.2 times Kp is 2.0396 plus or times B over L, so 3 divided by infinity. So, since meron tayong infinite value, so 3 divided by infinity, alam natin na that is a value approximately equal to 0. So, although may value siya, kaso ang dami niyang decimals before having the magnitude, which is 3. So, 3 times 10 to the negative 6, ganun. So, that is approximately 0 na agad. So, multiplying this term by 0, we have a 0 value. ang matitira na lang yung 1. So, our lambda CS now will just be equivalent to 1. Then, for the lambda QS, parehas sila ng value ni lambda gamma S. So, that will be 1 plus 0.1 Kp B over L. So, parang ganito din yung mangyayari. So, we have 1 plus 0.1 or 0.1 times 2.0396 times 3 over infinity. So, yung 3 over infinite will be 0 again. So, as you can see, ang lalabas pa rin na lambda QS and the lambda gamma S will be equivalent to 1.0. Now, meron na tayong shape factor. Next, we have a depth factor. So, for our depth factor, we have the value, yung lambda CD natin dyan, that is equal to a value 1 plus 0.2 square root ng Kp df over b. So, okay lang naman kung kinuha nyo na yung square root ng Kp kasi ang square root ng Kp, that is just equal to tangent 45 plus phi over 2. Yan lang din naman yun. And that is still the same kung isa-substitute din natin dito yung value. May discrepancy lang siguro on the last third and fourth decimal. So, that will be, substitute na natin 1 plus, so 0.2 times square root ng 2.0396 times yung df or yung embedment depth ng footing which is 1.4 divided by yung b which is 3. So ngayon hindi na magsi-zero, magkakaroon na tayo ng value ng lambda CD which will be equivalent to 1.133. So yan na ngayon yung lambda CD natin. Now, we have to compute for lambda QD and the lambda gamma D. So, for this value, we have 1 plus 0.1 square root ng Kp, that is df over b. So, that will be equivalent to 1 plus, so that is 0.1 times square root ng 2.0396 times 1.4 over 3. So, calculating this equation, we have the value of lambda QD and the lambda gamma D equivalent to 1.0666, which is unitless. Then, on the part of the inclination factor, since na-solve natin siya on the Terzaghi's equation, sa Terzaghi kasi, vertical lang yung load doon. Based on our previous video on the assumption of Terzaghi in deriving that equation. So, ibig sabihin, ang theta natin will be equivalent to 0. And having a theta equivalent to 0, all the inclination factor, which is our lambda CI, lambda QI, and the lambda gamma I will be equivalent to 1.0. So, ngayon, yan yung magiging inclination factor natin based on the equation from the Bowles textbook. So, ngayon, since Meyerhof's bearing capacity equation to, ang gagamitin nating bearing capacity factors will be the equation for Meyerhof's. So, alam natin na sa Meyerhof's, yung NQ niya tsaka NC parehas lang from the Terzaghi's. So, ang NQ natin sa Terzaghi kanina is 6.3994. And yung NC natin doon will be equivalent to 14.8347. Ngayon, ang isosolve na lang natin will be N gamma, which has an equation NQ minus 1 times tangent of 1.4 phi. So, that will be equivalent to, so substitute natin, 6.3994 minus 1 times tangent of 1.4 times 20. So, our N gamma for the Meyerhof's equation will be 2.8709, which is unitless pa rin. So, having these factors, we can now compute for the ultimate bearing capacity using the Meyerhoff's equation. So, we have the value of C, which is 20 times 14.8347 times 1, which is the N gamma, or the lambda CS, times the lambda CD is equal to 1.1333 times the lambda gamma, or the lambda CI, which is 1 din. Plus, so yung Q and Q natin, yung Q natin is 1559 over 100 times our NQ, which is 6.3994 times the lambda QS, which is 1, times the lambda QD, which is 1.0666, times lambda QI is 1. Then, plus 1 half. Gamma natin will be yung 919 over 100 times B is 3 times 1 half gamma B. Yung N gamma natin is yung 2.8709 times our lambda gamma S, which is 1, times the lambda gamma D, which is 1.0666, times lambda gamma I, which is 1. Our QU now will be equivalent to a value 484.8655, which is in kilopascal. So, ito na ngayon yung bearing capacity natin using our Meyerhoff's bearing capacity equation. So now that will be all for this video regarding sample problem for the ultimate bearing capacity of the continuous footing, which is 3 meters wide. So for our next video, we will be solving the square footing, which has a dimension of 3.5 meter by 3.5 meter, and the water table is at a depth of 1.5 meters below the base of the footing. So again, this is Engineer Rodolfo. Thank you for watching, and don't forget to subscribe to Butch TV.